Hi, good morning, and thanks for joining me here in my shop on February 5th. What am I going to do? See all those capacitors? I'm going to make all those capacitors disappear. All of them. There's a lot of them in there. Holy smokes, there's just tons of them. So they look, for wax capacitors of this vintage, they look to be in really good shape. Are they in good shape? That's an interesting question. I like to test the old parts when I remove them from a radio, just to keep me honest about what's going on here. There is something interesting though that can be done with these capacitors. There's one here that clearly has been cooked. It lives between the output tube and the rectifier tube right here, and it's surrounded by higher wattage resistors. And look at it. So it raises a question in my mind. Is this capacitor more deteriorated than, let's say, this one way over here? Interesting question. What I plan to do is take this one out and another as an example, test both of them and compare them to each other. Just see if, in fact, what it looks like is what it really is. Now, I think I'd like to stay first in the audio area of the radio. So we look for something like the volume control. So, and then the output tubes over here. Here actually, one of these two anyway. You see a RF coil here and RF stuff over here. So the audio capacitors, what's this one here? Sensitivity. Phono sensitivity. Is there a click switch here? Yeah, okay, so you must flick it to phono. Otherwise you're adjusting, maybe this is an RF gain control here. I don't remember doing anything when I was testing the radio, but maybe I just didn't check it close enough. So, well, if it's RF gain, then this is part of the RF circuit here. It's going into this tube. Oh, this yellow wire, the yellow wire goes way up in here. It would appear to be in the IF string. That's what it looks like. So I think these are probably RF. This is probably an RF capacitor. And then this tube, well, here's this coil. So I think it's everything from here over. That's 1, 2, it's only 3. So what I'll do, there's others hooked up to the volume control. I'll do these 1, 2, 3, 4. I'll do these 5 capacitors, and we'll test them separately. This ugly one, it's kind of self-marked. It's so ugly, but I'm going to put an extra mark on it here, so I can recognize the really bad guy. Okay, I'm going to cut these out one at a time and replace them one at a time until I get all these done. Then we'll run them all through through a tester. Okay, there's the 5 dead soldiers there, and we're going to test them on here. We'll start with that really ugly cooked up. Oops. Uh-oh. First. Okay. That's part of the test procedure there. Throw the capacitor on the floor. Oh, it is really roughed up. It is in really rough looking shape. So the trick with this guy, it's not really a trick, is the eye here, which you see is open, will close if there's any current flow between these leads. Tiny current flow when I run the test. Okay, so I'm going to put 50 volts on the capacitor here, and the eye should snap closed and then open up just like that right away. Let's see what happens. Oh, geez, this is the crummy one, and it worked. Okay, 150. Look at that. It's still opening. Can you believe it? 250. I'm sure it won't open now. So we got all the way to 150 with this guy. I'm surprised. Okay. Certainly not like new. The next one we'll try is this one. Type 85 TOC. And you know what? I don't even know what that means. I tried to find out. I couldn't. So, thermal T 85 degrees? Is that what that is? I don't know what that is. A lot of the capacitors are marked with that. In here. Okay, 50 volts. Right open. 150. Right open. 250. So this capacitor is fine. There's nothing wrong with it. Let's give it a test on its size now. 0.003. Should be here. Watch for the eye to pop open. Right there. And that is 0.005, 0.004. Very close to 0.003. But it reads higher. Generally, this machine will read higher if there's a bit of a leak. So I think that's another evidence of leak. Plus, this isn't opening up all the way. I think it's all indications that it's a little leaky. It's gone anyway. It's not in the circuit anymore. Okay, we'll go back. 3 more to test. I think they're all going to come out pretty much exactly the same. Let's see. These ones all look to be in good shape. Look at the seal on the ends. Well, you know, for a capacitor that's been in there for so long, yeah, it's in good shape. Does it work well? 50 volts. It only partially open. So this is actually worse than the cooked one. Isn't that interesting? It looks good. Looks better. Not look good. Looks better, but works worse. 50. A little better. 150. Can't do it. One more to go. Oh, Peanut. Yeah, I hear you out there. Come on, Peanut. Come on, push that door. Come on, Peanut. Come on. Come on. Come on. See, he wants me to go out. Well, he knows him coming in doesn't get me out. Come on, Peanut. I'm almost done here. Okay? I know, you want to go over there. I know that. Okay, never mind the cat. He's just going to stay in the doorway. Their cats are they have a system of politeness, cat politeness. It's similar to human politeness in many respects. Apparently speaking when other people are talking is not part of it, but here we go. 50 volts. Right open. Partially open. They're all pretty similar. Worthy of replacement. Okay, my kitty, I'm coming. Okay? Hey! No, this way. Hey! You heard my voice echo, maybe. Yeah. Oh, he's coming in. He's coming in. Yeah, it's coming in to make sure. Okay. I'm coming out. We'll have to start the radio up in a bit. Okay. Here's the 5 capacitors I just put in, plus the one I put in earlier. Let's see if the radio still works. So there is a procedure called shotgunning capacitors, where you just change them all at once. Not recommending that. Even doing 5 at once involves a little bit of risk that you've made a mistake while you've done it. And mistakes can be hard to find. One of the things I do when I'm cutting out the old component, as soon as I cut a lead, I clip this onto the terminal, and I cut the other lead, I clip this on the terminal. Then I can look away and do stuff, and when I look back, you know, I got the terminals clipped. I can't get confused. It's so easy to make a mistake doing that, and that's why I want to start the radio up at this point, convince myself it's still working. before I put more defects into it. Just these guys want to short here. I don't want them to short. Okay. Let's put that like that. Cord. Okay. On off is off. We're on AM. Receive. High tone. Phono. We don't want to be on phono. Maybe we'll find out what this actually does. I'll turn it up. We're good. We're good to go. Let's see. Let's just turn this back a wee bit. Okay, so we're going to go through the dim bulbs here. Whoops. Small radio. Just going to go through this one bulb. Here we go. Nothing should happen. Very good. And here we go again. Something should happen. Wow, is that ever bright? That is bright. That is very bright. It's okay though. Lights are on over here. It's only 40. Yeah, it's only 40 volts making it. So I'm going to screw in this other light. Now we're going to get 95 volts, 100 volts. It can take a long time to warm up. Let's take it off the dim bulbs here. There we go. Well, that's a little nerve-wracking. Yeah, must be RF. RF gain. Okay, broadcast. Yeah, radio's working. The antenna's not switched on down here. I'm pretty sure. So let me go do that. I'm going to put this right on. I think 640 is right there. 640 AM. I'm going to go through the antenna switch. Let's see what happens. Nothing happened. Oh, you know, there's a good reason for that. Well, I never connected the antenna. That would be the reason. So on this radio, if you're going to hook up a single wire, then you would close this link and hook up a wire here. What's really going on is this is kind of feeding into what I'd have to look at the schematic to be sure, but I imagine it's feeding into a transformer. And so you got to feed through the transformer. So if you hook up just one antenna lead here, it's going to kind of work, but you really need the other one to really get it going. Because this is not a single wire antenna, this is going out to a folded dipole in fact. So let us hook this up. Just turn it down a little bit here. So there's nothing grounded about these two terminals, but this is a ground. Didn't make a lot of difference, did it, when I did that? Okay, just put this up there. Now let's see what we can get. Come on. Could be the particular antenna I have switched on. So I'm going to go switch to a different antenna. Let's see if that works. Don't want to do it. So as far as I know, the capacitors I did are only in the audio section of the radio. So the radio part should be working the same as it was, but it doesn't seem to be. Seems a little worse. Not to worry about it though. Let's try some shortwave here. This time of day, you know, it'd be up around 13 maybe. That's C band. So I'm pretty sure this is 9330, a very strong signal. Barely being picked up. Okay, well, we're not going to worry about how well it's working until all the capacitors are changed. And the next round of capacitors, turn it off here, flip it over again. Oh, son of a gun. That was not a shock, that was a burn on that tube. Oh boy. There you are. No telling what you're going to learn when you watch my videos. Oh boy. Just can't keep on top of everything, can you? So I think it's just I think it's a minor thing. Wow. That's unforgivingly hot. And I know that. So that was a good strong lesson. Liable to not do that again. I'll never play the violin again, no. Okay, so in terms of doing capacitors, let's see, there's 1, 2, 3, 4, 5, 6 kind of in the center area of the radio, and then there's a bunch over here. Not that their physical location necessarily guarantees anything. Why don't we do this group of 4 over here? These 4 guys. They're all hooked up to this tube. What's that tube? Hey, you're gonna burn again, fool. it's a hot tube. 6BA6, so it's just one of the RF amplifiers or IF amplifiers or something like that. Okay, again, we'll do those. Actually, you know what? There's three clumps here. There's a clump here, and a clump there. This is the IF string. I'm guessing it's going probably going this way, and then that might be the mixer tube. I don't know, just guessing away here. No reason to guess. So IF string. Don't know what that is. Let's do these 3. We'll do these 3 next. Well, hey, you gotta make decisions here. 3 to go. Okay, I've got those capacitors in. Checking that they're soldered. Yep. Now look at my poor finger. That one there, it's got a welt on it from where I touched the tube. You know what that is? That's a wealth of knowledge. Okay, now that the laughter's died down, let's try this radio here. Okay, speaker not shorted. Whoops, 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 whoops. Okay, back down to the single bulb. Switch is off, switch is on. Power is on through the bulbs. Tube is out, tube is out, tube is out, tube is in. Ooh, did you see the light flash? Maybe my hand was right in front of it there, but when I put the tube in, that light flashed from the rush current going into the heater. Hello, Shadow. Welcome aboard. Okay, Mr. Radio, you should be making some sound. All right, voltage, good to go. Hello, radio. Whew. Wow, lots of volume now. One of those capacitors I changed actually carries the entire audio signal from the volume control onward. And that particular one may have been reducing the signal a bit. Hard to say. I'm doing too many capacitors at once to really know. Where are we? Let's just go up. Hey! How'd that happen? So we're up around 860. That's the French station. That's a tough station to get. That's right, Shadow. So I think it just made a big difference here. Yeah. Couldn't get that before. .640s just right in there. Shadow. Hey, careful. A little on the shortwave side. Band C again. Yeah, things are coming and going on shortwave, of course. Let's try up here. Pretty quiet. Let's go up another band. Okay, D band. 15. Nobody home. Okay, let's just keep going. Right, Shadow? Look into the camera, Shadow. Now speak. No, she won't speak. Okay, good. More capacitors to do. Hey, let's flip it over and just take a look. Power's off. Cords out. Hey, gonna burn your finger again, Jim? Is that the plan? It's not the plan. No finger burning. Okay, 2 more clumps to do. Got a clump here. A clump here. These are all tied into this one tube here. I wonder if this is the detect. No, I pulled that out already. I already went through that exercise. Well, let's do these 3. We'll do these 3, check the radio, do the last 3, And we'll see. What do you say, Shadow? Is that a good idea? You going to help me out here? Yeah, I'm sure you are. Hey, we've got some capacitors to check. Wait a minute, wait a minute, wait a minute, wait a minute. Wait a minute here. Let's check these quickly. It shouldn't really be any different than the rest, I would think. Just slightly leaky. Some of these capacitors are in circuit positions where there's no electrical pressure on them. There's no voltage across them. So if they're leaky, how big a deal could that be? 50 volts first test. Right open. 150. Partial. Similar, of course, to the other capacitors because they've been traveling together in the same bus for quite a while. So I would expect them to kind of have similar stories at this point. 50. Not quite open. 150. Not going to do it. So this is a little worse. It's just kind of a relative test you can do here. You have to build up a bit of experience to get to know what good and what bad is. Now that's bad. That's definitely bad. This is a big one, wasn't it? 0.1. Okay. Did I check them all? I think I did. Who cares? We know what they are. We know what the situation is. Really. Okay. This bunch next. Getting all ready for lunchtime there, are you, Shadow? Oh, it's almost is lunch. Okay, that's 3 more in. Oh. Almost got a short there. Okay, that's good. Soldered up okay. And these ones here. This interesting copper band. Okay, what's left now? Well, we should test the radio. One more test. What do you say? What do you say, Cat? Speakers, good. Power. Dim bulbs. All is well. Good. Hey, what's happening? What are you looking at me for? Boy, this radio really commands patience. Lots and lots of volume. Okay. AM band. Get a heterodyning in there. Not much else. Seems very different. Well, that sound? I think that's an oscillation in the IF. I'm not sure. We used to get 860 here. Now we just get a swooshy sound. That's not very reassuring, is it? But we have more capacitors to do. Lots of volume on short wave. Not a thing. I saw it. I was making some interference in it. This band spread should probably be on yeah, on 0. I'll help it out here. Yeah. If you want this dial to be at all accurate. Well, it's not picking up very much, is it? "14 to 16 is repeated. 14 to 16. Still connected, right? Well, it's going great. I think it's going great. A few more capacitors to do, then we can worry about the complete lack of performance here. Don't burn your finger. There they are, the last 4. But you know what I'm going to do? It's lunchtime here. So, hey, Shadow. 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 Hey. Hey. She never responds. Well, let's go have some lunch, Shadow. Okay, got that done. Let's take a look now and see what 15 capacitors get you in this radio. Good catch. Okay, speaker wires, antenna connected. Switches off. Dim bulbs away. Speed things up here. I heard something snap. What did I hear? Looking for smoke. I should have kept it tipped up on its side here. Ah, that's a good sign. Okay, let's give it the full juice here. Okay, down to the broadcast band again. Loads of volume. Still got the swooshy sound. Now we were picking up the French station here very faintly before. Maybe that's what that is. Maybe that's the carrier. We're not going to listen to it. Okay, 680. Gone. Whoa, whoa. The wrong spot. So if it's moved on the dial, I would guess that means the oscillator is running slightly different than it was. Yeah, so those sounds used to be under the civil defense dot. They've okay, it just seems to get crappier and crappier, doesn't it? So on the band, let's go on to band D, 14 megahertz. 15. We'll put on the oscillator here. That makes it a little more sensitive, at least for us listening. Band C, 6 megahertz. That's interesting. What was that? Okay, how about in here? Sure. Nope. I'm assuming this dial is somewhat accurate, but it's not picking anything up. Well, there you go. That's what you get for 15 capacitors and a couple hours work. Okay, not to give up. Not to give up. It's just step one. Okay, that's great. Well, thanks a lot for watching, and never fear, alignment is near. We should get something out of this radio, I'm sure.